Hey Kafkuba fans, this is part 2 of my Robbins and Myers vintage fan deconstruction and reconstruction video. I'm checking all the electrical stuff now. I just did rotor checks. I went commutators side by side and got like 10.4 all the way around. I had as little as 9.7 sometimes and as high as 11, going from commutator segment to commutator segment. But on average it was 10.4, 10.6 dead nuts. Then I did commutator segments directly across 180 degrees from each other all the way around. And that was 62 ohms dead nuts all the way around. And then I checked every commutator segment to the shaft for continuity, and it was open all the way around. Just as an example, that's the shaft, and I went all the way around, and even on some areas around the commutator ring. So there's no short circuits. The resistances are all consistent from winding to winding. So I'm very pleased with that. So I'm going to call this rotor satisfactory to clean and move forward on. The there's a little wear in the copper, but for an old fan, I'm just going to clean this up eventually. The next stage is going to be cleaning this all, but I'm not going to go nuts. I'm just going to be very gentle. Now, the other mystery I had going in the last video where I took everything apart was this switch. And let's see if I can get a better view for you. You can see all my stuff set up here. So I haven't found this anywhere online, not a schematic. I found nothing on Universal Motors, hardly anything. Nothing at all, actually. I did find some random patent sheet which shows the type of switch I have and these resistors with no value, but this is just a general Universal Motor patent, which was kind of fun to find and semi-useful, at least for making sure I'm on the right track here. So I was looking around for resistors on Ohmite web pages and stuff like that, thinking about, I couldn't find any ratings for this fan. It's a 115 volt AC. That's all it says, but it also says it's a DC. Also says it's a DC motor, which is a universal motor. That's fine. But like for a current rating or anything like that, I was just like trying to size resistors in my head, thinking, okay, 115, it's drawing 1 amp. I can kind of get to the rating of the resistor that way. But then I came home and I was like, okay, let me check this out. Well, first of all, let me show you. This was the cable coming in from the wall outlet over here. And one side goes to this lug, which attaches to the switch under here. So the current's going to flow from here. It's in the off position now, but it'll go high, medium, low speed. And the other side of the incoming line from the wall outlet goes to this slug and off to the motor and returns to the motor. But on the way back from the motor, if it hits this high speed connection, there's no resistor there, so it's going to be full speed. As it comes here, well, now you're introducing a resistance between here and here. And then if you go to low speed, you're doubling that resistance. So you'll have two, this is like some kind of center tapped resistor. So off, no connection. High, the wire bypasses the resistor. Medium, it picks up one leg of the resistor and low speed, it picks up both legs. So I was like, okay, let me measure this resistor. Maybe I can reverse engineer it when I go to buy a new resistor. Well, I came here and I checked, and I'm getting, it was 62. It seems to take a while to charge up because I think it's a coil in there, a wound resistor, so it takes a while. And I get 62 ohms. I don't know if you can read that with the reflection. Just my luck. See that? 62. And then I came to the second leg, and that's also 62. It was like dead nuts matching. If I go across all of it, say for the low speed setting, it should be double that. And you see it's about double. So I'm thinking I'm not even going to mess with this resistor. Yes, it could heat up and go bad, but I'm going to do some thinking on this. The resistance seems to still be good there. So that's how that works. And I don't know. I don't know if that's ceramic or asbestos or what that is. But yeah, so this switch might be a keeper. I don't know. It's not like I'm going to run this fan 24/7. I'm going to get it going and that's it. Hold on, let me reorganize this desk a little here. So I trimmed up these wires. This cloth, man, I used those nippers there, and that insulation is pretty tough. You would think it would flake off at this point after 80 years, but I could barely get wire. So this is the, if you remember, I labeled these 1B and 2B. These are the brush wires. So these come off the brushes. And all I got is hair. Well, that can't be right. Hold on a second. Is there wax on here? Or these doodads killing me here? These rubber boots. So let's see. Am I measuring this right? Am I thinking this through? So this is 1B and 2B from the brushes. Overload. I'm not trusting that. Let me check the mains. Are these in series and I'm not like doing this right or something? Hold on a second. It's bad enough I can't think. I gotta keep this fucking multimeter from falling over. That says overload. That doesn't make sense. Am I plugged in? Yes. Duh. Let me check these resistors over here. There's a test case. You gotta be kidding me. Alright, so that's coming down eventually to 62 ohms that I measured over there. Hold on a second. You slippery, sliding bastard. I'm a victim here. Unless I tore the wires when I was taking this apart, that doesn't make any sense. Let Let me think this through. Hold on. All right, so since this is a series wound motor, I tied because the main coil has to be in series with the armature coil, you know, from the brushes. So I tied one of the brush wires to one of the mains, and then I took the series reading, and I'm getting 51 ohms or so. So to me that checks out. So let's see if let me change this to continuity, this cheap piece of shit, and let's see if we got, I'll take off one of these and go to the case. Then I'll go to the core, case, laminations, go to this wire. Oh, I won't see. It's too much resistance for the continuity meter to go off, but I'll just go to this one, make sure it's working. So I just short right there just to make sure the continuity is working. And then let's just check around again. Case, inside a case where it's not painted. Laminations, screws. Everything seems fine. So electrically, other than some wiring cleanup here, and it gives me hope that it was so hard to strip back this insulation that it might be holding up pretty good, but you can see as we get close there's some sus stuff going on. But I'm confident now that the stator's fine, the rotor's fine, and actually this switch might be okay, but I have to give thought to this fire hazard concept and see if it's something I want to live with. So I think electrically we're ready to move on. Sorry for the camera movement and all the asbestos fuzz. Thanks for checking this out. I'm going to think about cleaning up the housing and blade, and I still got to clean the oil out of the oil bucket. But all right, thanks. See you later, guys.